All right, we'll give Haunted House a try. All right, we are at the outside of the house. There's paper on the ground. Now this has pretty simple. You would think you could say like take take paper, but it doesn't work. Get is the command it wants. The inventory command, we have the crumpled paper. What are we doing? We're at the outside of the door. Open the door. Oh, it can't be opened. Why don't we read the paper? So we're back to Colossal Caves, but in this case it's Plu. Alright, so we're inside the house. Great. In the living room, there's a knife levitating in the middle of the room. Alright, let's get the scroll. Alright. Alright, oh, I am dead. And we can't restart, which with the emulator is not a big deal, but with a real computer is a super big deal. To understand why, let's look at how we do this on a real Model 1. We have to do system, and then Haunt is the cassette name, and then we hit play on the cassette. I'm using my PC, and it takes over a minute. We've skipped ahead, but to give you an idea, then you can hit slash and you're running. We can do all the stuff we did. So I'll skip ahead. And when we die, like I did before, we have another minute load. So to fit this game in a 4K level 1 machine, a little bit of trickery with the cassette is going on. I've kind of diagrammed that out. There's 2 cassette files on the one tape. There's kind of the haunt that you load to start with. Then later in the game, there's second floor. So in a CAS file, we see haunt.cas, and then after the bottom of that, there'll be second floor.cas. So I'm showing that's how you load it to start it up on the upper right. And in the middle, when you get halfway through the game and are going to do the second floor, you kind of do an action and it says ready the cassette, and then it loads in that second floor. So there's sort of an assumption you left the cassette going and you got to that point, and the cassette will get turned on again and load the second floor, and then you can play the second floor. So between having to reload the cassette when you die in the game and the odd paused tape to go to the second half of the game, this is a bit annoying to run this adventure game on either the real hardware or on an emulator. So what if we have the idea that we can patch this game to get rid of these inconveniences? Restart the game when you die and automatically load the second floor. It's a bit of a distraction, but let's give this a try. It'll also give us a chance to use TRS-80 GP, which is George Phillips' emulator, and trld, which is a tool that he includes in his collection of TRS-80 software. So we'll get a good chance to put those tools through their paces as we attempt to make a patched version of this game that's more playable. Before I go on any further, I definitely want to note this is kind of a silly hack. At Computer Archaeology, I think it's .org. I'll post the link down below. This game has already been completely disassembled, but I didn't take the disassembly route. I'm actually trying to use TRS-80 GP to sort of reverse engineer the parts that I need to make this work on a real machine. The disassembly project was would be a lot easier if you had the assembly source code. You could make all these changes without the shenanigans I'm going to jump through here. But this was more an interesting exercise in a hack and using some of the emulator tools and messing around with it. And I also did all my own playing of this. I didn't look at any walkthroughs, which is why I didn't find the disassembly till quite a bit later. But I didn't. This is kind of an interesting alternative to disassembling the whole haunted house program. But that site's there, and I'll link it. Very interesting to see how this program is put together in more detail than I go into here with the full assembly source code. All right, so let's go over our plan of attack to set this up. What we're going to do is, I'll use this diagram. What we're going to do is we'll start with the overall cassette file that has two cassette files in it, the haunt.cas and secondfloor.cas. We're going to separate those into two different cas files. We'll call the one start.cas and the second one secondfloor.cas. Then we're going to use George Phillips TRLD to convert these into ROMs. This will put us with the bytes that would actually appear in memory. All the other memory will be zeros. This is going to be very handy for what we're going to do next. What we want to do is load the start cassette where it should be, but then we're going to load a copy of it. This is the copy we'll reload with our own code. We're going to have a tim patch over here that we'll put at the bottom. If we die, we want to use the patch to, instead of jump forever, we'll go back into our code, copy this start back into this one, and then put the program counter back where the program originally started. That's how we'll restart. Second floor will patch for the cassette load when it goes to the second floor, and we'll have a copy of that. Rather than doing the cassette load, we'll go back into our code again and move the second floor where it belongs. It's about halfway through the start. Most of that is data. It's kind of an overlay of data. Once we have this ROM, this thing here is going to be a ROM, we'll convert that to a cas, and we're going to have to do some hacking because we'll have a lot of zeros. One of the nice things is that we can use playcast to tell us that the checksums we have when we go and edit that thing in our records, we'll go through the cassette format in a bit here, that it's wrong, and it'll tell us what the number should be, and we can just edit that in a binary editor. So that's kind of our plan of attack. Let's start off by creating start.cas and secondfloor.cas. We'll do that by breaking haunt.cas into the two files. In the right-hand window, I've got the cas file format. Here's haunt.cas loaded in the HXD binary editor. We'll use this editor to make our changes. But starting off, the playcast program is useful. We'll load up haunt.cas, and it has a nice export function to put out the cas file as text, sort of showing what's in that window so you can read it. I'll bring that up in an editor. This output has some information we need, including the start address of the program, which is 42E9. Let's jump down in the editor to the secondfloor.cas file, and we can see where that begins. 435E is where second floor loads. It's an overlay of the existing memory the program's using. We notice that second floor wants to set the program counter to 000H. This is probably not what's going on. It's probably calling the cassette routines in the ROM directly, and it's not actually going to use that 000 memory address. Finally, in this first cas file, I want to double check that it is jumping to 42E9 at the beginning where the load started and not somewhere else. And in fact, that's the transfer address. That's great. All right, at this point, we can go back into the binary editor and separate these two haunt.cas into, we'll call it start.cas and secondfloor.cas. Looking at the documentation, at the very end should be a byte 78 followed by where it sets the program counter to. We can use the hex search to find all 7/8s in the file. I realize there's going to be a lot of extra 7/8s that aren't those, but cas files start with a whole bunch of zeros, so we can sort of look for that kind of pattern. And there we go. And in fact, 42E9 is our address, so we can highlight all of second floor and delete it. And the remaining bytes should be what we want in start.cas, so we'll call it that and save it to our file. All right, great. We're going to open the original back up again, and we're going to sort of do the opposite. Start at the beginning. And you can see the zeros at the beginning of the cassette, and this time I'll just kind of search down. Oh, there it is again, 7842. We'll take all of that up to where the zeros start and delete that, and then we can save this as secondfloor.cas, and we've separated the two cassette files that were in haunt.cas into useful separate files. And we're going to use playcast to double check that these are valid. This is a great check. This little tool will help us figure out if we've got any errors or we copied the wrong stuff. And we'll go to second floor. We looked at start. And this all looks great. No problems. Before we go on, so far we've got like two CAS files. Those aren't very useful for sort of the copying of the start and second floor that we want to do. We need to get these bytes in how they would actually look in the computer. The CAS file is kind of a stylized per record with all kind of bounding information that is sort of a very good representation of what goes on the cassette tape as bits if you change the sound into bits. We need to see it as it wouldn't be in the computer, and the type of file that we're going to use is called a ROM file, and TRLD will convert those from the CAS file to the ROM file. Back to our directory, we can see start.cas and secondfloor.cas. We'll use TRLD to convert them from CAS files to ROM files. We just type the name of the program and change the extension. That's start, it's now a ROM. And second floor, just change it to a ROM. We're done. Now we can take a look at what this did in the binary editor. So let's open up start.rom and take a look at it. What we immediately notice is a lot of zeros. That's odd. But remember, this is what the memory looks like inside the TRS-80 after this is loaded. So we could use the CAS file to remind us that the data should actually start at 42E9. Great. So if we go back and scroll down far enough, we should expect to see the haunted house start. There it is. Perfect. Right where we expected. And this goes right up to the edge of the 4K limit. It's in fact 1 byte before it's using up to the last byte of memory in a 4K Model 1. So let's do the same thing with second floor. We need to scroll down because that should appear at 435E. And in fact it does. It's a bit shorter, but again that one goes right up to the edge of 4K in a Model 1. Okay, so now we have the two ROM files. So we've got another quick diagram to show what we're going to do here. So the first thing we'll do is we'll start off with the start.rom, which will have the beginning of the start memory. And I've diagrammed out, this is at 42E9, and it goes through 4FFF. So we'll place the second floor copy at 5000. I've also noted there'll be a couple of things we need to know, like where we load the start and where we load the second floor. So we've got the addresses of that. Now, if we do the math, the start of the start copy will be at 5B43. And then if we add that up again, 685A is where I can start putting code. Let's go. We don't want to overwrite start.rom. We want to save that. So we'll make a copy of it into haunt2.rom, and that'll be our working file. So let's bring that up in the hex editor. All right, there it is. No surprises. It's exactly the same as start.rom. Let's actually load secondfloor.rom and start.rom into the editor as well, so we have those in tabs because we're going to be copying stuff from them into haunt2.rom. All right, so we want to scroll way down to the bottom of this. And the interesting bit is, you can see it down at the bottom, is that the insert address is hex 5000. Now we can copy the ROM for second floor into this file. So we need to scroll past the leading zeros and highlight all of the interesting bytes here. Then we'll copy that out of secondfloor.rom. and paste it into Haunt 2. All right, that looks good. It starts at the right address. That's great. The unsaved part is white, so it's easy for us to tell what we added. At this point, we can check that the address 5B43 is where we're going to insert our copy of start.rom. That looks correct. All right, so let's go over to start.rom, and again, we scroll down past the zeros, and we're going to highlight the interesting bytes. All right, good. And copy. And paste that in. Excellent. So we now have a copy of start.rom up front, second floor.rom, then another copy of start.rom. And in fact, 685A is correct. That's where my code will go. So that was the pretty straightforward part. We just used trld and we used some hex editing to get the files together. Now it gets a little tricky. Before I can write my code, I need to understand what happens in this program when the player dies. So that's what we're going to turn our attention to next. After that, we got to figure out how the cassette load actually happens in the implementation so that we can copy second floor into the right place at the right time and can return control to the haunted house program out of my code. But let's start by figuring out when the player dies, we'll focus on the haunted knife, what actually happens in this code. And we're going to use TRS-80 GP to do that. And as we'll discover, this is very straightforward using the debugging tools inside TRS-80 GP. So many thanks to George Phillips for this. It's really, really useful for this kind of work. All right, so let's pick up playing. We got to the foyer, and we're in the mysterious room with the knife. We get the scroll, and we try to read the scroll, and we die. At this point, we need to see what's happening inside the TRS-80. So we open the Z80 debugger, and we can see that we have a jump statement jumping back to the same address, sort of an infinite loop. The jump instruction is 3 bytes in machine code. It starts with C3, and then it'll have the LSB and the MSB, so it'll be 484A in this case. Great. We now know how Haunted House is dealing with the player's death. It infinite loops with a jump statement. So we can patch this jump statement to jump into our code and do the restore of the game rather than jumping at the same place over and over again. This is great. We'll not do that right now. Let's continue to reverse engineer in TRS-80 GP. We need to discover how second floor is loaded. So we'll investigate that now. So the first thing we're going to use is a bus use record. So we need to get to the part of the game where we're going to do the second cassette load, and we move over from debug and hit record on bus use. In the original tape, we type climb rope, and it will prompt us with ready cassette. And when we hit return, it will do the cassette load of second floor. So this is the part we're interested in, is when does ready cassette actually happen in the code. Hopefully this bus use, which is recording information about the data and disassembling it a bit for us, which we'll save into a file here, will help us out. All right, so we're going to use my editor to go into this bus use trace. George has a lot of interesting documentation up the front of it. Hang on, we'll get this up. All right, bus use second floor, which if you read, make a little more sense. It's a little tricky to use these. It's intermixed with kind of code and data definitions. This part here looks like we have a lot of text, but it's actually just the data storage for a lot of these strings. So we need to get past this to find the area we're actually interested in. All right, we'll skip a bit to where we find it. Okay, this is it. This is what we've been looking for. org42f5. This is where the code outputs ready cassette and then inputs the carriage return. This is exactly the location we need, and this is where we're going to patch the code. All right, so we now know where to start our special load of second floor. What we need to figure out, the last address we need to figure out, is once the cassette load is done, where does the program counter go back into the haunted house code to start running the second floor properly? This turned out to be the hardest address to find. And I even consulted with George Phillips and was using a new feature in TRS-80 which is ranged breakpoints, where I can set a start address and an end address and break the debugger at exactly that point. I'm going to do this, but I want to sketch how this is done because it's a little bit tricky. So the first thing I use is that I know the address of when the ROM is used to shut the cassette player off. So I'm going to break on that because I expect the code to shut off the cassette player when it's done reading. We'll break there. We're inside a ROM address. Then we'll enable another breakpoint that covers the entire range of our program. So once the ROM code finishes, it should go back into our code at exactly the address that we need to start the second floor. Alright, so here we are in Haunted House right before the cassette load for second floor happens. We'll set the first breakpoint, and I'm sort of going to make these bigger at the bottom so you can see them, at 1F8, which is the cassette off. The second breakpoint, and when I start entering it and it's checked, you'll see the program stops because I'm going to put it from 42E9 to 4FFF, which is where the program actually exists in memory. To start off, when the second floor cassette load happens, we want to uncheck the program range and just include the cassette off. So in the emulator, we'll type climb rope, which is the magic thing which gets us up to the second floor. Hit return on ready cassette, and if you look in the upper right of the emulator, you can see the stars appear because the cassette load is actually happening. Now, if we watch this, it takes a little while. We're hopeful that we will actually run that cassette player off routine and the code will break right at the breakpoint I've already set. All right, there it is. The program broke. We're in the stop cassette routine. So we don't really care about this address, but now we set the range for the whole program and uncheck the stop cassette routine and restart the program. Boom, didn't take long, and we've got our address. 435E is the address where the second floor portion of Haunted House starts running. We can see it setting up the stack pointer and then proceeding to run the game. This is great. This was the last address we needed. We can confirm this by hitting go, and we can see the program actually start running right where it should. That's it. That's the last address we need. So now we need to turn our attention to writing the assembly language tim patch ASM that we talked about in our overview. This will contain a short bit of code that we'll use to change things around, to do all the copies we need to, fix the patch jumps to reload and bypass the cassette load routine and just copy memory. This is fairly small bit of code, but we'll walk through it. And don't worry if you don't remember all of the hex addresses from the earlier parts. These were all jotted down in this assembly language as I went down, so I didn't remember them either. All right, so here's my assembly language code. Recall, after we did all the address calculations, this code my tim patch wants to run at 685A. That's the address. So we'll kind of skim through this and then we'll go in depth. There's a bunch of addresses that we're kind of defining as constants here in the program. The first one is where does we've called it start, but it's the haunt cassette. Where does it load? And then we note where it ends, and we do a calculation here to figure out how many bytes that is. We do the same thing with second floor. That's where it wants to load. That's where the last byte of it is, and we calculate the size of it. Now, we are going to do our copies. They're there, so we got to track where those things are. We want to use them in the code down below. So we've just jotted down that we're putting second floor copy at 5000, and haunt copy is going to go at 5B43. So now there's two places in the game that on the first floor and the second floor, I've called them knife patch and hole patch, which are those infinite loop jumps. There's actually a couple other places you can die, but the code all ends up at these, so they're sort of like death patch, first floor, death patch, second floor. Those are the two addresses, and we'll see the code that needs these. Now, these are the two addresses we just figured out. The cassette patch, which is where we start with the prompt for cassette ready. This is where we want to jump out of the normal program. And then we know once we're done with the copy of the second floor code, here's the address where we want to sort of enter the second floor. We have a routine that restarts the game. We'll skip that. And then we have a load second floor routine. We'll go over those. Here's the main program. This is what we want to run right before the game actually starts. Let's skip over everything. What we're going to do is when we get done with this stuff we're going to work on, we want to jump back to haunt load, which, let's recall, that's 42E9, which is where the program would have normally started. So we're going to end up starting the program normally. Now, the interesting bit is that we could take the approach to do these patches where what we do is we go into the hex editor and we start hacking up the original copy and the copy for start.rom and the second floor.rom and patch the bytes. We didn't do that here. The approach I took was this code actually goes into the right places and patches the addresses that are needed. I think this is more visible and easier to recreate. So you can think of it as those ROMs load as they normally would, and then this code runs and changes kind of modifies the code to jump into our code. And what we're doing here is we want to restart the game when we die. We're going to add there's 2 bytes, the low order bit and the high order bit, and we're going to use high and then low in A here, high and then low, and copy those first into the original copy of Haunted House. And then this big long calculation, all that's doing is figuring out where in our copy that this should be made. So it's just a little bit of algebra. This one does the same thing. Notice we do skip over the jump byte. We're actually a byte after where we start the low. And it also is a little bit weird because normally you'd think it would be high, low, but the Z80 in memory actually does low order bit, then high order bit. Okay, this is the same thing. We've got another one of these in second floor. Restart the game, restart the game. The algebra has to be there. There is no original copy of this, so we're into our copy. All right, and here's the one that actually does the cassette load. The first thing we do is load the jump operation, which, if you recall, probably don't, but it was C3. That's the jump op, and we patch that in right at cassette op. That's easy. We don't have to do anything special. Then we figure out where we have to load that into the copy as well. So we've loaded it into our original one and then the copy. Now we're going to load second floor and the low order bit into the original copy of start ROM and then our other copy, and then the high order bit of start second floor.rom. And there it is. Now, those are the 3 patches we have to make. Now we turn our attention to what we patched in. First one was restart the game. That was the address we were doing, and it's right here. It's this little bit of code. And what this code does in a nutshell is it uses the kind of nice Z80 elder instruction, which copies a lot of memory. And we set it up so that we set the beginning, the source of the copy at our Haunted House memory copy. We set the destination at the original place where Haunted House should load, and then we load the size and we run that, and that copies all the memory right in that little thing. Then we jump right to the beginning, and that's almost as if the cassette loaded and we restarted it, except we did it really fast with memory, so that's nice. Now load second floor is pretty similar. We do the start from the copy, but we set it to where second floor loads, which, if you recall, is like an overlay, so we put that in there. We only copy bytes for second floor, and then we this hard fought one, where do we start second floor, we just jump to there rather than to the very beginning of the program. And that's all there is with this. It's pretty straightforward. All right, now that we have our assembly language, let's exit the editor. We're going to use zmac, which is the assembler, to assemble it. That was simple. Next thing we want to use is trld. We'll take the cassette file. I'll take the 500.cas here. Hang on. And we need to change this into a ROM. Just like we did with the other files, we want to do timpatch.rom. All right, great. So we have a ROM file. Back to the binary editor. In the editor, we have our working Haunt2 ROM. We're going to load timpatch ROM next. A lot of zeros in this, and there's just a little bit of bytes that came out of assembling that ASM file that we created. So we need to copy these to the end of Haunt2 ROM. So we'll copy, go to the end of that. Now when I did all this, I triple checked that all the addresses were right. If the org in my assembly did not match where we're posting it, it would be very bad and things would not work right. So we paste it in there, save it, and we're all set. We have our complete ROM. Now we need to get this thing into a CAS file so we can load it on our real computer. All right, one last time with trld. We're going to change the Haunt2 ROM into a CAS file. All right, very good. Notice the warning here. That's a symptom of what we have to deal with. Let's load it up in the binary editor. Okay, so where this went wrong is all those zeros got put into like where the cassette thought it should load starting at 0 and put all those zeros into memory, and that's not quite what we want. So we're going to hack this up to be correct. I won't go through the gory details of this, but the basic idea is after the cassette header, we are going to cut and paste all those records that just contain 0. You can see me selecting just after Haunt2 gets started. And then I delete everything. Now, we just have to adjust the size and the checksum of that very first record to be correct. And we'll use playcast once we've edited the file to double check that we got the right checksum. That's kind of our basic strategy. This is pretty simple to do. Recall at the bottom of the cassette file, after this hex 78, we need to put the lower order byte and then the higher order byte of where we want the program to start. And for us, that's 42E9. That's our main. We don't want to go to the beginning. We want to run our main. So here I'm hex editing that and saving it. And then we're going to go ahead and load this particular ROM into playcast and double check that it's all good and that in fact we are jumping to our main. And I think we've got a usable CAS file to run a 16K version of Haunted House. All right, that's it. I originally planned on making this a video with that little hack, which was quite involved when you explain it, and we'll play through a Let's Play on the same video, but this is way too long. The next video will be the Let's Play, so you get to see the CAS file in action, and we'll play through the game and see how it is. In the video description, I'll include links to all of these tools and also a link into GitHub where all of the artifacts I created are, including the final CAS file. So if you're interested, you can get them at GitHub, and I'll include links to all of that. Thanks.